after part 1, part 2, part 3. See, in part 3 basically what we did was we started calculating the differentiation of a basic polynomial. So for example, I think now we are okay that if I am given a function like say fx is equal to say x cube plus 3x square plus x, if I am given a function like this, then I will be able to take the differential. Are we comfortable with that? One thing.
Yeah.
Now again and again, in every of the lecture what we are discussing is that they can write this as fx is equal to x cube plus 3x square plus x square, or they can write it like y is equal to x cube plus 3x square plus x. It is one and the same thing. All that we need to understand, Avantika, that we need to keep in mind is that what we need to see whenever we are given a polynomial or whatever, a trigonometric function or exponential function or logarithmic function, one thing which is very critical to us is, which is, what we discuss every time in the first few minutes of the lecture is, what is my independent variable and what is my dependent variable. Have you understood?
Yeah.
See, that is what is very critical for us, and I'll tell you why. So for example, in physics, what we will see is, we will see function like these. X is equal to function of time, and that function of time is written as t cube, because what differentiation or integration that we are doing right now is concerning physics. We are not concerned much about the general terminology which is used by mathematicians. Have you understood, Avanti?
Yeah.
So when we'll be doing physics, and our focus is to understand how all this differentiation that we have been discussing for the last 3-4 lectures, how is it applicable to physics? That is what is important for us. And in physics, we will see a function like this. So what they will say is that a displacement is a function of time using this function. Have you understood my question?
Yeah.
So what they will say is that a displacement is a function of time. That basically what they will say is that there is a particle which moves as per this given function. Have you understood my question?
Yeah.
Now there I should be very comfortable in getting the point that this is the time axis and this is my displacement axis. Are we clear?
Yeah.
The time is a independent and xt is a dependent variable. Are we clear?
Yeah.
There we shouldn't get confused that ye kya ho gaya? This x should be actually the x-axis, and where is this y? Have you understood the confusion? Because this is what I was discussing with you when I was in class 11. This is the confusion I used to face. कि यार ये how is this x a function of time? जो x है वो तो x-axis होना चाहिए. So we should be very clear about this. Are we okay?
Yeah.
And another thing that we need to understand, of course, slowly we'll understand. So the point that I'm making is कि because in physics we'll see question like this, that x is a function of time like this, and then they will ask us what is the velocity, what is the acceleration, etc. Another thing that we need to understand is, so for example, they give us a function like this. They will give, so for example, coming back to maths, they give us a function like this. Now one thing that we need to understand is that we have discussed in previous lectures also, this dy by dx can also be written as f dash x. Have you understood what I have said?
Yeah.
And another thing that we have discussed in the last lecture, I will repeat, that I can take second differential of the function and I can write it like f double dash x. Is it making sense?
Yeah.
Let me clarify this with an example. So for example, if we take this function only. Now if I take the first differential of this function, the first differential of this function would be equal to 3x square plus 6x plus 1. Is it making sense?
Yeah.
This is the first differential. The second differential would be written as, the second differential is basically a differential of the differential function. So this would be written as 6x plus 6. Are we comfortable with this?
Yeah.
And how it becomes critical for us, how this terminology becomes critical for us is because when we are given a displacement function in physics, because again and again my purpose is to take you back to the applicable of derivatives using physics. So when we come to physics, what they will say is that there is a displacement function which is given to us, and then they will ask us what is the velocity function. So the velocity function, if you have understood, the velocity function would be equal to 3t square plus 60 plus 1. Avantika, is it making sense? Avantika, is it making sense?
Yeah.
And similarly, the acceleration function. The acceleration function is a differential of the velocity function. or is a second differential of the displacement function. Am I making sense?
Yeah.
So if I have to write the acceleration function, the acceleration function would be written as 60 plus 6. Are we clear till here?
Yeah.
One thing that we need to be very clear, before we start going ahead with today's topic, one thing that we should be very clear is that this is a function.
Mm.
This is also a function. This is also a function. Are we clear?
Yeah.
Now, and that is why we have been discussing that you need to be very clear about the graphs of the functions also. So for example, this function would be a cubic function. So approximately it will look something like this. This would be a cubic function. This is a quadratic polynomial. So its graph would be a parabola. It would look something like this. This would be a parabola which will open up. And this acceleration function would be a straight line. I'm drawing very rough graphs. Have you understood what I said? So what I'm trying to tell you is that this function, so for example, in terms of physics, this first function is a cubic function. The second function, which is a differential of the first function, the displacement function. So this is our velocity function, this is a parabola, and this acceleration function is a straight line. Are we clear?
Yeah.
So, but one thing again that we need to be very clear is that this is the time axis. In the first graph, this is the displacement axis. In this second graph, this again is a time axis, but this is a velocity axis now. Are we clear, Avantika?
Yeah.
In the third curve, this is the time axis and this is the acceleration axis. Are we clear?
Yeah.
So, whenever we see a cubic polynomial, whenever we see a quadratic polynomial, whenever we see a linear polynomial, we should be very clear. We should be actually very comfortable how the graph will look like. Are we clear?
Yeah.
And if you are confused about how the graphs look like, then I think this is basic algebraic graphs for all. This is one of the very important lecture for us. Avantika, are we clear?
Yeah.
Okay, now we come to the topic of what do we want to discuss in this lecture. What we want to discuss in this lecture is we want to basically understand this question. In this next 30-40 minutes, what we try to understand is a question like this. Consider a particle. Now this is where you will understand the application of physics. This is what we want to spend time, maybe today and maybe tomorrow also. This is where we'll see whatever we have learned for differentiation being applied. So the question is, consider a particle traveling along a straight line such that its displacement s meters from a fixed point O, t second after it passes through is given by. So the displacement function, I can write this as like this also. So the displacement function is written as minus t square plus 4t. Now this is the question which is given to us. Now what they will ask us in this question is, they will ask us few basic questions like what is the velocity function of this graph, of this body, what is the acceleration function, and few questions based on this. Have you understood?
Yes, sir.
So for example, they might ask, find an expression in terms of velocity for velocity of this particle, draw the graph of velocity, state the values of time for which velocity is positive, 0, negative. What is the direction of motion when velocity is positive, 0, negative? Find the acceleration of this particle and interpret your answer. So, this is something we won't go into much depth, but this is something that we should be very comfortable with. Have you understood?
Yeah.
So this is what we want to discuss in this topic, that how do we use our differentiation to understand. We will be able to calculate given a displacement function, we will be able to calculate the velocity function and the acceleration function. That is what we will be able to do. But now what we want to do is we want to interpret the result. That when is the velocity positive, when is the velocity negative, when is the acceleration, how is the acceleration like, is the acceleration constant or is it decreasing or increasing, and in which interval it is decreasing or increasing. Am I making sense?
Yeah.
Okay. So we come back to, leaving the physics part, we come back to the maths part, and we try to take a general function and we try to understand. So the rest of the discussion we will keep for understanding the maths part of the problem. So there is a function like this, y is equal to fx. This is how it looks like. Now what you need to understand is, because we know that dy by dx is basically my slope. So if I look at my slope, if I look at these four graphs, in this case the slope would be negative, and that is what is being shown by the dy by dx also, that it is negative. In this part the dy by dx would be positive, in this part again dy by dx would be negative, and in this part the dy by dx would be positive. Avantika, is it making sense?
Yeah.
Okay. Now the interesting thing for us is that points like these, here the slope is 0, and that is why you see that the dy by dx is equal to 0. Is it making sense?
Yeah.
Okay. Now what I'm trying to tell you is that if I have a graph, if I have a function, so for example let me take any random function. So for example I have a function like y is equal to say x cube, let me take x cube minus 3x plus 1. So this is the function which is given to me. Now I take the first differential, so y dash, the first differential, this is x cube minus 3x plus 1. So I take the first differential, so this would be equal to 3x square minus 3. Are we clear?
Yeah.
Okay. Now looking at this slope function, this first differential is what do we call the slope function? The slope function. This slope function will tell us the behavior of the slope of this function. Am I making sense?
Yeah.
Okay. Now let me put this 3x square minus 3 is equal to 0. Why would I put this as 0? I'll just let you know in 2 minutes. So x square minus 1 is equal to 0. X is equal to plus 1 and minus 1. So let me analyze this result for you. The slope function 3x square minus 3 is 0 at 2 points. One point is plus 1, another point is minus 1. Are you with me?
Can you just repeat once again?
Okay. The slope function becomes 0 at 2 values of x. One value is plus 1, the second value is minus 1. Are we clear?
Yeah.
Any doubt till here?
No.
What does this mean graphically? What this means graphically is that the graph that I have, the original function that I have, this original function, this is the, you have to remember that this is the original function. The original function will have slope is equal to 0 at 2 points. One point would be minus 1, the other point would be plus 1. Am I making sense or not?
A little.
Okay. Let me repeat. This is my original function. Are we clear? When I take a first differential of the original function, it is a slope function. Is it clear?
Yeah.
The slope function, if I put it as a 0, there are two x points, plus 1 and minus 1, where this slope function would be 0. Am I making sense?
Yeah.
Now, what I'm trying to tell you, Avantika, is that if I want to analyze this result, what I'll say is that dy by dx at x is equal to 1 and at x is equal to minus 1, at these 2 points, the slope of the function are 0. Am I clear?
Yeah.
At these 2 points, my function will have 0 slope. Why? Because at these 2 points, the slope m is 0. Am I making sense?
Yeah.
Now these 2 points would be either like this. These two points can be like this or like this or like this. Am I making sense?
Yeah.
So what I'm trying to tell you is that if I add these 2 points, minus 1 and plus 1, basically the function would be either like this or it will be like this. Why? Because the slope at these 2 points is 0. Am I making sense?
Yeah.
See, I'll repeat. This is the function and this is the differential. This is the differential and this is the function. Am I clear?
Yeah.
So this point is called local maxima. Am I clear?
Okay. Yeah.
And this point is called local minima. Am I clear?
Yeah.
Am I clear?
Yeah.
Now, what I have understood till now is that this -1 and +1. What I have understood is that at these 2 points the function will have a zero slope. Are we clear till here?
Yeah.
But now what I want to understand is that okay, minimum slope तो है, जो slope है वो zero तो है. But what I want to understand is that point a local minima or a local maxima? Because local minima पर भी slope zero है और local maxima पर भी जो slope है वो zero है. Are we clear?
हाँ.
Are we
Yes.
clear till here? Okay. If we are clear till here, then you will understand the meaning of what you had noted. That, see, at this point and at this point, what you see is that the slope is zero. Slope to bhai zero hai. But the difference is this point is a local maxima while this point is a local minima. Am I making sense?
Yeah.
If I'm not making sense, let us look back at the function that we had discussed 2 minutes back. So my fx was x cube minus 3x plus 1. My f dash x. My f dash x is the slope function. I'll repeat. My f dash x is my slope function. What does my slope function do? The slope function gives me the slope of the original function. And if I put this slope function to be 0, I have 2 points, x is equal to plus 1 and minus 1. So what I suspect, actually I don't suspect, I know that at x is equal to plus 1 and at x is equal to minus 1, the function will have 0 slope. Are we clear?
Yeah.
Now my job is to understand which of these would be local maxima and which would be local minima. Are we clear?
Yeah.
Now let us try to understand that. Now so these points where the slope is 0, that this is what they are saying. Gradient is a 0, is called a stationary point or turning point. So this is where the graph will turn, but whether it will be local maxima or it will be local minima, that is what we need to understand. Are we clear till here?
Yeah.
Yeah? Okay. So my slope function is 3 x square minus 1. I can write x square minus 1 as x plus 1 into x minus 1. Are we clear till here?
Yeah.
Okay. Now look carefully, and if you don't understand, please ask as many questions as you can. So I need to trace this function. This is my slope function. Now what I know is that this slope function, this function at x is equal to minus 1, this, if I put x is equal to minus 1 here, the slope function would be 0. That is what I have understood. The value is 0. Now let me look at the left side of this point, the left side of this point. So let me take any random point like minus 2. When I take a point like minus 2, which is on the left side of minus 1, and I put here, so this would be minus 2 plus 1, this would be minus, and minus 2 minus 1, this would be positive. Is it making sense?
Yeah.
So minus plus minus into plus is minus. So here my f dash is negative. Am I making sense?
Yeah.
Left of minus 1, the slope would be negative. Are we clear?
Yeah.
Okay. Now let us look at right of minus 1. So I'll take a point somewhere here. Let me take 0. So if I put 0 here, 1 into minus 1, again it is negative. Are we clear?
Yeah.
Are we clear why it is negative?
Yeah.
So minus 2, no, there's a mistake I've done. 1 second. If I put negative here, minus 2 here, so this is minus 2. Okay, so if I take a point which is on the left of minus 1, so let me take minus 2 here. So when I take minus 2 here, so this would be minus 2 plus 1, this would be minus 1, and minus 2 minus 1 would be minus 3. So minus into minus is plus. So actually my slope function is positive on the left side of minus 1. Am I making sense?
Yeah.
let me analyze what happens to my slope function on the right of -1. So let me take another point, say 0. So when I take 0 and I put 0 here, this becomes +1 and this becomes -1. So 0 -1 negative. So my slope is negative this side. Are we clear?
Yeah.
In 2 minutes things will start falling in place, don't worry. Again I take a point which is on the left of +1. Let me take 0 again. So when I take 0, I know that when I take 0, let me take another point, like maybe, so that things become clearer. Let me take a point like half. So if I put half here, this half plus 1 would be positive this side, and half minus 1 would be negative this side. Plus into minus is negative. So left of +1, my slope is negative, and if I take any random point which is on the right of +1, let me take it like 3. So 3 plus 1 is 4. This would be positive. Avantika, are we clear till here? Now let us try to interpret what is happening. So at this point -1, my slope on the left is positive. The slope is positive. It reaches 0 and then it turns negative. Is it making sense? Avantika, is it making sense?
Yeah.
Again, if I look at +1, on the left of +1, the slope is negative, comes to 0, and then takes a positive turn. Is it making sense?
Yeah.
So slope, if it changes from positive to 0 to negative, this point would be local maxima. Is it making sense?
Yeah.
If slope changes from negative to 0 to positive, this would be local minima. Is it making sense?
Yeah.
So what I have analyzed is that for this function, Avantika, the at point -1, basically point -1 would be the point of local maxima, and point +1 would be point of local minima. Is it making sense?
Yeah.
Okay. Now let us come back to physics and try to understand what does this imply from a point of physics. What it implies from a point of physics is that if we are given a function like this, that there is a particle, like we saw before, there is a particle which moves as per, or let me take example from the book also only, so that things become easier for you. So I'll show you that example, but what I want to show you now is that how does it make our life in physics easier. So I will send you the page scan. So for example, at page number 406, the question is that there is a particle which moves in a straight line. The displacement of the particle is given by t cube minus 12t square. Actually, what I'll do tomorrow is I'll take few examples from your NEET paper, so that you get confident that questions are asked on this topic from NEET also. Otherwise, you might be thinking, "Arey sir, pata nahi kya karte ja rahe hain." So for example, this question, what they are asking is that what is the velocity at t is equal to 2. This is the first question which is being asked. The second question which is asked is find acceleration at t is equal to 4 seconds. The third question which is being asked is find the value of t when the particle is instantaneously at rest. Have you understood?
Yeah.
Now, this is what I want to arrive at, that how do we answer this? Particle is instantaneously at rest. Have you understood this question?
Yeah.
Now, with the background that we have, we understand that the particle would be instantaneously at rest, where the velocity function would be 0. Have you understood?
Yeah.
So, what we need to do is we need to find the velocity function. The velocity function would be 3t square minus 24t plus 45. The acceleration function would be 60 minus 24. So I can put this value of 2 here and I can find the velocity. I can put the value of t is equal to 4 here and I can find the acceleration. Am I making sense?
Yeah.
And if I want to find the time at which the particle is instantaneously at rest, I need to put my velocity function as 0. Am I making sense?
Yeah.
So basically what I need to do is I need to put this 3t square minus 24t plus 45 is equal to 0. Is it clear?
Yeah.
And because it's a solved example, so I'll tell you the one second. Yeah, the at time t is equal to 3 seconds. I will send you the solved example. At time is equal to 3 seconds and 5 seconds, the particle is instantaneously at rest. Am I making sense?
Yes, sir.
Okay. Now D part, what they are asking in the question is, I will share the question with you. D, what they are asking is distance of the particle from x from the origin when t is equal to 7. Now what they are asking is that what is the distance of the particle at t is equal to 7 seconds. Now this part is simple because I am given a displacement function. I am given this displacement function. I put the time t is equal to 7 seconds and I can find the displacement of the particle from its origin. Are we clear till here?
Yeah.
Okay. And the last what they are asking is, the last thing that they are asking is what is the total distance the particle has traveled. I'll show you the question one second. So this is the question that we are discussing. This is the question that we are discussing. So we can calculate the velocity, we can calculate the acceleration, we can calculate where exactly the particle was at rest. We know that at rest the instantaneous velocity would be 0. Are we clear?
Yeah.
And find the total distance of the particle from origin when t is equal to 7. Are we clear? Now what he is saying is find the total distance traveled by the particle during the first 7 seconds. He is asking us the total distance. Now if you look at this part, so at the particle was instantaneously at rest at 2 points where the velocity was 0. This is what I told you, that at 2 is equal to 3 seconds and t is equal to 3 seconds and t is equal to 5 seconds. Now if you look here, that the displacement function is Avantika, I'll restart the meeting. Just give me a second.
Sir.
Yeah, just give me a second. Before I start writing, I'll restart. 1 second. So basically when we look at this part, E, find the total distance traveled by the particle during the first 7 seconds. Now this is where our knowledge of maxima, minima and the positive negative sign will start making sense to us, and we will be able to understand how these things are helping us. So this is my displacement function. Avantika, are we clear?
Yes, sir. Sorry, I was on.
So yeah, so this is my velocity function. This is the first differential. So this is how it will look like, and my velocity is 0 at 2 points. One is at 3 and the other point is 5. Are we clear?
Yeah.
So at 3 and 5, I basically know that my particle will come to rest instantaneously. Are we clear about this? Avantika, are we clear about this?
Yeah.
So because what we need to understand is because my velocity function has become 0. So it is like saying you take a ball, you throw the ball up. At its highest point, the velocity would be 0. And if we interpret it further, what we will see is, let us assume that up is positive. So velocity while going up is positive. From positive, it becomes 0 and then it becomes negative. Have you understood?
Yeah.
So in this case also, something has happened to the particle that it has changed direction. It might have changed direction. This is what we suspect. And to further investigate that what exactly would have happened, what we take is we take this point t is equal to 3 second. On the left side of t is equal to 3 second. Wait. On the left side of t is equal to 3 second, what we see is that left side of t is equal to 3 second. Let me take a point like 2 second. At 2 second, my velocity function 2 minus 3 negative, 2 minus 5 negative, negative into negative is positive. So my velocity function is positive. Avantika, is it clear? Avantika, is it making sense?
Yeah.
On the right side of t is equal to 3 second, I take a random point like 4. If I put 4 here, 4 minus 3 is positive, 4 minus 5 is negative. So positive into negative is negative. So the velocity function is a negative on the right side of 3 second. Is it making sense?
Yeah.
So what we can understand with our base of maxima minima is that around t is equal to 3 second, the velocity changes from positive velocity to negative velocity. Is it making sense?
Yeah.
This is the same like saying my stone has reached the highest point and from there it is coming down because the velocity is changing from positive to negative. Are we clear?
Yeah.
Again, using the similar knowledge that we have gained from maxima minima, if I start analyzing my particle at t is equal to 5 second, on the left side velocity is negative, on the right side my velocity is positive. So again the particle has changed direction. Are we clear?
Yeah.
It is like you were going on a road, you forgot something, you came back and then you realized nahi wo to hai mere paas, and then you went back on the road. Are we clear?
Yeah.
Okay. Now let us try to see how does this look like. And I am again and again I'm insisting that this is something that you will find in competitions. So don't think that फालतू की बात है. Maybe tomorrow I'll discuss 4-5 neat questions with you, in which this differentiation maxima minima would be used. Are we clear?
Yeah.
Okay. So this is my particle at t is equal to 3. At t is equal to 0 second, it starts moving. Let us assume this side. Now at 3 second, my velocity is 0. So how I interpreted this is that it was going this side, and then something happened. It changed its velocity. It became negative. Are we clear till here?
Yeah.
So at 3 second, the total distance that the particle would have covered is 54 meter. How did I find this? I used t is equal to 3 second. I used this function x is t, and I found the value of my displacement at t is equal to 3 second, and I found this to be 54 meter. Are we clear?
Yeah.
So till 3 second, my particle had come to 54 meter mark. Now, what I want to see is that again, what I know is that at 5 second, it changed its direction again. So it was going in this negative direction. So basically you were coming back to your home to pick up the thing that you have left. But again you realize that you already have that in your car and you turned in the positive direction again. Are we clear till here?
Yeah.
So now let us examine what is happening at, see, this is 3 second. 3 plus 2 second is 5 seconds. So this is basically my 5 second. At 5 second mark, if I see at 5 second mark, you are 50 meter away from your home. Are we clear?
Yeah.
You are closer to your home. Are we clear?
Yeah.
And then the question asks, let us look at the question again, what the question is asking. The question asks that the total distance traveled by the particle during the first 7 seconds. So the question is asking us about the first 7 seconds. This is 3 seconds. This is a total of 3 seconds. This is a total of 3 seconds. This mark is a total of 3 plus 2, 5 seconds. And after 7 seconds, the particle is at 70 meter mark. Are we clear?
Yeah.
So the particle at 7 seconds would be somewhere here, and it would be at 70 meter from the home. Are we clear till here?
Yeah.
Now, see, the point that I'm trying to make is that unless and until you are able to read the graphs, the slope of the graphs, how will you be able to make out whether the velocity is positive, negative, and where the body changes its velocity from positive to negative, from negative to positive again? Is it making sense?
Yeah.
Now, I understand that the things are getting a bit complicated, but you covered 54 meter till here. Have you understood?
Yeah.
Then at this time you were 50 meter from your home. So basically you would have turned 4 meter back. Is it making sense?
Yeah.
So this was 4, and from this 50 meter to this 70 meter you have covered 20 meters. Are we clear?
Yeah.
So therefore the total distance covered is 78 meter, while the total displacement is only 70 meter. Are we clear?
Yeah.
Now there's another thing that I want to tell you. Of course this is confusing the things far more than is required. If you look at the acceleration function, what the acceleration function is saying is that the acceleration increases with time. As time goes on, the acceleration is increasing. It is not constant. Avantika, is it making sense?
Yeah.
And that is what you will see in the motion of the particle. If you see from this point to this point, while going back, it was 2 seconds, but in 2 seconds it had only covered from 54 to 4. It had only covered 4 meter. But when it reversed direction, because it is an accelerating particle, in from 5 second to 7 second, in 2 second it is able to cover 20 meters. Am I making sense or not?
Yeah.
Because it is a particle whose acceleration is not constant. The acceleration is also increasing. Are we clear?
Yeah.
So, see, this is what I wanted to discuss. This concept of maxima minima. I'll send you these solved example. Just look at these solved examples, because we are not much interested in we are not very much interested in the solving extra tough questions which the maths people usually do, because the non-medical students would be required to solve these extra tough maxima minima questions. You are not required, but at least we should have a fair amount of understanding how these questions are done. Are we clear?
Yeah.
If you want, you can do one of the easier questions which won't require much of differentiation. This is a question that you can do if you want. Are we clear?
Yeah.
And as a homework, finally what you are driving at is that how does all this differentiation help you in solving physics questions. This is the lecture that you will have to see. Can you see this lecture? I will send you the link.
Okay.
So application of differentiation, find position, velocity, acceleration using calculus. Are we clear?
Yeah.
And again, as I told you, when we will be doing the direct application of this maxima minima would come when we will be doing simple harmonic motion. So there will be a block which will be attached to a spring. You give a force to the block, say left or right side, then the block starts moving in like this simple harmonic motion. When we do this simple harmonic motion, again these maxima minima differentiation basics we will be using. So there'll be a displacement function, then we'll be able to draw a velocity function out of that. We'll be able to draw a acceleration function out of that, and using our concepts of maxima minima, we'll be able to see where the velocity is 0. So basically what I'm trying to tell you is that at the extreme position, you will understand when the block is at the extreme position, the velocity is 0. Have you understood? Because the block has to come back. Is it making sense? Avantika,
Yeah.
am I audible? So again, when the block is the blocks comes here, again the velocity will have to be 0 because it has to change direction again. And these things, see, what we know by intuition, these things would be visible in the equations also. Am I making sense?
Yeah.
See, you just need to have a flavor of the maxima minima. This lecture would be easier for you. This lecture would be easier for you because in this lecture, maxima minima are not used. When we are doing simple harmonic motion, we will come to this lecture again. And then I will discuss with you that how this maxima minima basics are affecting you. Are we clear?
Yeah.
So tomorrow's agenda is few questions from NEET which require differentiation, and then if time permits we'll start integration. Are we clear? Miss Avantika, are we clear?
Yeah.
Okay, so I'm stopping the meeting. Yeah.
Yeah.